Dao Aquila wrote the first paper on retrieval augmented generation and is the CEO and co-founder of Contextual AI, a company that's raised nearly $100 million to help enterprises build customized contextual language models for their use cases. Dao was previously the head of research at Hugging Face. He spent 5 years at Facebook AI research, and he's an adjunct professor at Stanford. He was the perfect guest on unsupervised learning to talk about a bunch of things, including innovations in post-training, his view on OpenAI's latest O1 model and reasoning in general, barriers to enterprise deployments, and the research areas he's paying attention to. I think folks are really going to enjoy this episode. Thank you so much for coming on.
Yeah, thanks for having me.
So I think we're talking one day after the O1 release, and so I'd be remiss not to start there and just ask you, what do you think of yesterday?
Yeah, I think it's very exciting. I think a lot of us in the field have been thinking about test time compute, basically, right? And I think one of the things that's very interesting about the release is that it's going in this much more important direction, I think, of thinking around systems rather than models, right? So essentially what it's doing is it's compressing a lot of the chain of thought ideas that have been around for a while into the model using RLHF, which has been around for a while, and turning that model into a more complicated system, essentially.
Yeah.
So I really think it's very encouraging to see that this works so well for reasoning specifically. My own team has been working on very similar ideas, but then much more on the retrieval side of things, right? So how can we compress a lot of this systems thinking into models, or at least make sure that we address the entire system and not just kind of having this one thing that predicts the next word and that's it.
Right. And now that we have, a model out there like this, I mean, should we expect most future models to follow this approach, or?
Not necessarily yet. So I think it depends a little bit on the latency constraints of the deployment, right? So when you have to do a lot of thinking during test time, your latency goes up. So it's not always the best thing to do. I think there are all kinds of different trade-offs that you have to make when you think about AI deployments.
I thought it was interesting in the benchmarks yesterday. Obviously, it's much more powerful on certain things like math and law, but other things actually the old models do better at, and they're certainly much faster.
Yeah.
I think it'll be so interesting to see what UIs are built around the fact that like you might have to wait. I mean, this one, the wait time isn't crazy, but as you could imagine over time, there'll be models that you wait hours to get something back from, and how do you kind of build?
Especially if you have like very long context and there's a lot of like complicated reasoning that you have to do, then your thinking time goes up. But the same is true for humans, right?
Right. That is very true. When like a new model like this comes out, like, you're a guru in the space. Like, how do you figure out if it's, what it can't do? Like, obviously, I'm sure you look at the benchmarks, but what do you do to play around with it?
Yeah, so it's mostly looking at the benchmarks, and so I have a very good team, so I ask them what they think, and they give me their opinion. Yeah, it's always good to follow along closely with these kinds of releases. For us, I think it's very encouraging that we've been thinking about very similar things, but then in the retrieval space. So I think it's exciting.
Yeah,
I think it's possible that some of the ideas that are in O1 were already in other places, models, without them telling everyone explicitly. I think you can guess what I mean there. So this idea, it's not super new, but as usual with OpenAI, you have to give them credit for how they executed on it. I think they did a great job there.
Awesome. Well, I think that's probably a good segue to maybe talk about Contextual a bit. And I think, there's a lot of interesting angles I'd love to dive into today. But maybe the first is, you started this with kind of maybe a different thesis to model building than some of the other foundation model players. And I'm curious, like, you talk a little bit about how that came about and, over the course of building the company, the milestones that have kind of given you conviction in that approach.
Yeah. Yeah, so why we started the company was because we saw this frustration in enterprises where everybody was super excited about Gen AI, like this is going to change the world. But at the same time, it just wasn't ready yet for prime time, especially not in enterprises, right? We knew that RAG would be one of the solutions to a lot of these problems. We also knew
that because you came up with it.
Because we came up with it. But we also knew we could do much better than RAG, right? So RAG was an old idea, and so the original vision was actually much more ambitious than what ended up in the paper. And so what we're building with Contextual is that much more ambitious vision. And so I think how we're different from an OpenAI or an Anthropic is really that we think about things from kind of two core principles, I think, that are different. One is systems over models. So I just mentioned how encouraging it is that OpenAI is also thinking about systems, but they're still compressing all of that in a model. And we think a model is maybe 10, 20% of this much bigger system that has to solve the problem.
Yeah.
Right. And what you want to buy, if you're an enterprise, is the system, not the model. And then you have to build all the system around it, and it doesn't work. And it's very complicated to build amazing AI systems. And we are very good at that. And the other thing I think that we do differently is that we do not do AGI. I think AGI is a great idea. I think fundamentally it's a consumer product,
right?
Because you have no idea what the consumer really wants, right? So you need a generalist intelligence to satisfy their needs. But in an enterprise, you often know exactly what you want from the user, and you often do not want it to be a generalist, right? You want it to be specialized for this one particular use case. You don't want it, so this came up recently in a discussion with the bank. So in the European Union, if you use your AI system for doing a performance review that is very, very bad, you will get very heavily sanctioned. So now you have this generalist AI deployment, and you need to like constrain everything back again, right? So I think the right way to think about enterprise AI is really through specialization, not generalization.
Yeah, and you guys obviously do a really compelling job kind of tying the whole retrieval process, in the model directly to the outputs to the large language model as well, versus separating them out.
Yeah, so when you have that systems approach, and with this specialization component, you can really just say like we end-to-end specialize all the parts together. It's a very integrated system. And then we focus specifically on high value, knowledge intensive use cases where that really pays off, like being extra integrated and extra specialized.
Anytime we talk to some of these end customers and there's like a company selling one very specific part of the infrastructure stack or one, and they're like, put us together with like these other 8 solutions and you get something. They're like, I feel like those companies get dragged into like, actually, can you just please do everything for us, or please just like help us solve this problem?
Yeah.
And so I imagine that really resonates with the folks you talk to.
Yeah. So for us, we're kind of taking the opposite approach, and I think that goes against the startup playbook in a way, right? But
yeah, do like one very specific thing.
Yeah, it's like do this one thing and do that really well, and so you get this layered cake. Which is what you would use to build Frankenstein's rag, essentially. And we're saying we're just slicing vertically through that cake. And so that gives us a very nice compounding effect where, because we control the retrieval and the re-ranking and the generation and the post-training and alignment and fine-tuning and all of that, that just makes us very good at solving the problem. And that's what you care about in the end.
Yeah. And I guess I'm curious on the enterprise side, it feels like maybe from my seat, the things that have killer product market fit seem to be anything in code generation space, customer support, obviously, and then a lot of this like internal search, chat your docs type stuff. But you must see this at a far deeper level. What else are you seeing in terms of patterns of things that are actually getting deployed?
Yeah, the pattern I see in terms of things getting deployed is that there are still just lots of demos happening. Yeah, we are focused exclusively on production deployments, which is very different, right? So I think we still see a lot of very compelling demos built in this Frankenstein sort of layered approach that then when they get to real user testing just fail completely. That's not even just about like the machine learning side of things, it's also like the deployment, like everything around it, right? So like risk and compliance and security and operational
what are like the fall on your face things you see, like amazing demo and then like, okay, that did not work.
Yeah, so demos are often built on like, I don't know, like 20 PDFs or something, right? There's a lot of climbing, like hill climbing directly on the test set happening with those docs, right? So yeah, directly hacking the test set. And then when you expand that to the 10,000 PDFs it has to work on, everything breaks down completely.
You were the author of the first paper on RAG. So like, obviously now it's become, everyone knows what it is. It's become a standard way of doing things. But like, how did that work come about? Like, maybe talk about that a little bit.
Yeah. So we always joke that we should have come up with a better name than RAG if we had known.
It's kind of catchy. It's kind of catchy,
but still, it's it doesn't really do it justice.
What would you rename it if you had a choice?
Yeah, something with the word contextual in it.
Yeah, with the company. It would be.
Exactly. Yeah. So then I would have to name the company something else, I guess. I don't know. But how that came about was I have always been thinking about grounding in my career. So my PhD was on grounding language in perceptual information, right? So the very early multimodal systems at the time. So like trying to understand the meaning of the word cat much better by knowing what cats look like. So integrating pictures of cats into your machine learning systems, your NLP systems. So
pictures of cats always crucial for most machine
exactly
learning breakthroughs.
That's where you start, right? And then when we were at FAIR, I was working with Ethan Perez, who was my PhD student, and we were thinking about this grounding thing. Like, can't we just ground in Wikipedia? So we built this amazing prototype, sort of like the first version of RAG that actually worked, and that was mostly possible because of the amazing work by the FACE team. So Facebook AI Image Similarity Search, I think is what it stands for. So that's the archetype of the vector database, right? The very first vector database. So in a way, it was very easy to just try out that idea. And then what we had to figure out was how do you backpropagate into the retrieval mechanism so that you can actually train the system. So we didn't even consider that in the future, most people would not backprop into the retriever because that's too difficult. They would just use everything off the shelf, right? So we had this nice prototype working, but then unfortunately for I think visa reasons university reasons, he had to go back to university. He wasn't allowed to work with me at FAIR anymore. So then there were these other people in London, so Patrick Lewis and Sebastian Riedel, working on very similar problems in open domain question answering, which was like the killer use case for RAG. So then we teamed up, and out of that came really amazing collaboration. So I miss those days. That's really like the golden era of FAIR for me. After that, it became a bit less good.
I guess at the time of publication, was it kind of clear to you? I mean, it's just become such a standard paradigm way to do things. Was that apparent to you at the time, or was it like, oh, we'll see what people end up doing with this? And
it's never really apparent. I think anybody who would say yes there is probably lying, right? Like when papers come out.
I mean, the transformer paper, I feel like, is the canonical example of this.
Well, so I think that history has been completely rewritten on that paper, honestly. So when the transformer paper came out at FAIR, we were very underwhelmed. We thought it was a little bit silly. Because we had RNNs with attention, and it's like, oh, like if you cut the recurrence, then you can parallelize it better. It's like, no shit, Sherlock, right? And it didn't even actually work that well on the machine translation benchmarks that they were evaluating on. It was tiny differences, and it was all very finicky and stuff. So we thought, like, why not just do kind of sliding window attention, aka convolutions, right? So convolutional neural networks. So I think some of the folks at FAIR were working on basically the same idea, but then using the convolutions paradigm. So that came out a couple of months later, maybe around the same time, didn't get the credit. And then Google proceeded to rewrite history, where they invented like the AI revolution. This is something I think that actually just happens with historians in general, sort of like the great man storytelling, right? Or great person storytelling, I should say. But so in scientific history, we do a version of this where it's like the great paper. But that's not how it works. Like there was so much stuff going on at around the same time that it was very obvious that this was something you could do. It was mostly actually about the engineering contribution, like how do I get this to work so well? The reason transformers work so well is not because they're amazing, it's because they are optimal for GPUs. GPUs are the reasons for transformers, not the other way around, right? So maybe NVIDIA deserves all the credit. Or I would say the real credit should probably go to the people who invented the attention mechanism, because that was really a radical new way to distribute information across sequences.
Well, the history's still being written, so we'll see what specific points we point back to. But I think for a lot of major discoveries, a lot of times there's simultaneous work happening in a bunch of different places. And, I guess that's been true since you mentioned calculus, right?
Yeah, exactly.
I guess like on the RAG side, I'm sure enterprise come to you all the time and they're like, okay, here's the 17 things I want to do. And I'm sure you have this mental model of like, yeah, those 7, good idea. Those 10, like, never going to work with the current models. Like, what's your mental model today of like what you can and can't do?
Yeah, so I think the main question we often get from customers is, can I put this in front of my customers? And we tell them to be very careful with that. The higher value the use case becomes, the more risky it becomes to directly expose that to your customer. So we're really trying to help enterprises find the optimal sort of ratio of AI to human very much keeping humans in the loop, solving problems that are within reach now, and then over time you can make it more and more complicated. I think companies are becoming much more pragmatic about that now, actually. Like the first conversations we had when we were just getting started, we had companies go like, I want this like investor application, and it's just going to make investment decisions. And
that sounds great. If we're ready for that, let me know. Yeah. I'll start looking for other jobs.
So yeah, it's not that easy, right? So yeah, the more concrete you can make it, the better. So if you give investors great tools so that they can make better investment decisions, that's what you want to do, right?
Yeah.
So I think we're quite a ways out from really just replacing people in those kinds of roles. So.
Yeah. And I know you've obviously, a big focus of your work in Contextual has also been around alignment and a lot of the work you're doing on reinforcement learning. And I think one, it'd be helpful for our listeners if you could just explain some of that work, but also like it feels like that space is moving so fast, and there's been all these improvements, and obviously there's the reinforcement learning from AI feedback, DPO. I mean, there's like a soup of acronyms I feel like in this space, and so it might be helpful to just kind of contextualize what's been happening.
I like
Contextual for contextualize. What's been happening over the last year, and kind of why you guys have chosen to focus here and what you've been doing.
Yeah. I think alignment is a super interesting problem area, right? It's really kind of getting at the core of like how do we make systems maximally useful for the end users, so as you know, right? If we take a step back, kind of RLHF was really the secret sauce that made ChatGPT work. There was some instruction tuning, sort of SFT, right? So just next token prediction. But then you can't really capture human preferences all that well. So what you ideally want to do is capture it at the full sequence level. So not at the next word level, but the full sequence level. So then the right way to do that is through RLHF or some similar method. So RLHF is great, but it has two big problems. One is you need to train a reward model, and so that you can propagate those rewards back to your sequence, right? And that model needs to be pretty good itself, right? So it's very expensive to train that model up, and then so you're kind of throwing that model away. You're never using it in your actual generations.
Right.
The other problem is that you need to have preference data. So that means that let's say you have a real deployment of a system, and you get like a thumbs down, like, oh, actually this was the wrong answer. Now you need to go to a data annotation company, or you need to have somebody internally annotate what the thumbs up would have looked like. So that's obviously very slow, very expensive, and doesn't
certainly the more specialized your use cases get, the more expensive.
Exactly, yeah. So ideally you want to break both of those dependencies. So if you can do this without a reward model, that's much more efficient, right? So that's what DPO was about. And then what we looked at Contextual together with Kawin, brilliant Stanford student, was can we break the dependency between the preference pair? So can we directly optimize on the feedback without needing to do data annotation? So we did that through something called KTO, another acronym, Kahneman-Tversky optimization, after the behavioral economists, right? Utility theory, and prospect theory. So really brilliant work, I think, from Kawin. And so we recently went a step further with this, with Carl, who interned with us, where we looked at the kind of under-specification problems in alignment. So one of the big problems with these preference data sets, or even if you have individual like thumbs up, thumbs down, is understanding what the real preference signal is.
Yeah.
Right. So you just have kind of a random ranking of like a bunch of answers, and you say like this one is better than this one, but you don't really capture why, right? Or like what the underlying sort of causal structure is. So one way to make that much tighter is to do contrastive revisions. So rather than having two options, you say like, this is an option, there's something wrong with it, let's fix it. And now say like, this one is better than this one, but it's only a very small difference, and like the difference is the fix.
Yeah.
Right. So that means that it's much less underspecified. So that's called Claire. And then when we were looking at Claire, we found that there's a very interesting relationship between the data and the model that isn't really captured in the standard RLHF or even in the DPO KTO paradigm. You ideally want to factor in sort of how good is the model that you are training your preference data on. If the model is better than the preference data, which is possible these days, right? It's kind of a crazy idea, but so it's possible that that's the case. So then you don't want to learn from that preference data that like this good one is what you should be doing. You just want to learn like this one is better than this one. There's still information in there, but you want to get the right information out, right? So just the ranking, not like this one is the right answer. This kind of anchoring on what the model quality is, we call that anchored preference optimization, so APO. So I'm very excited about this because you can just see, and we see this ourselves in customer data sets, you can just see this work much better, and you have much more control over sort of what the quality of the data set means for your model quality after you've trained it.
I mean, it sounds like you're doing a lot of reinforcement learning with your customers for whatever their use cases are. Like, how does that actually work in practice? Are they having people like, rank these things? Are they staffing folks to label data? Are you just using external parties? Like, how does that actually work with the customer?
Yeah, so we have our own data annotation team, our data engine, our customer deployments, when we deploy with them, they give us a lot of feedback. So we have a thumbs up, thumbs down mechanism, and we can learn from that very directly using our algorithms, which you couldn't really do with a standard RLHF approach. So yeah, I'm excited about that. But honestly, a lot of this alignment work just happens for the core model. Right. So just during post-training, I think that is also one of the things that, so alignment is a big part of this post-training, but post-training really is where a lot of the magic happens in AI, right? It's like, okay, we have this pre-trained model, but now we need to make it actually be good at what we need it to be good at.
Totally.
And so, yeah.
And you're obviously aligning it around a set of business use cases versus the ability to both do Shakespeare sonnets and give you a really, dry customer support answer the next day.
Yeah, exactly. Yeah, we always say if you want to use AI, right? Let's say you work in finance or something, you don't need that system to know about quantum mechanics or Shakespeare or Japanese haikus, right? You need it to be really good at that one particular thing. And you get that through alignment, right? It's just much more specialization, customization, and through that approach, we find that you can make it past this production bar much more convincingly, like integrated system, custom alignment, specialization. That you can see real ROI from these deployments. Yeah.
Super interesting. I mean, speaking of other research you've been doing, you obviously, I think, recently released this really powerful small MOE open source model. And I'm wondering, I think it obviously begs the question. It feels like a model of that size you can kind of run on device, and it feels like there's this overall trend of, potentially a lot of things moving on device. So wondering, one, what inspired the work, and two, is that a trend you expect to see a lot over the next few years?
What inspired the work is Nicholas.
Usually it's a set
the
of people,
first author on it, so it's all about people, right? And so Nicholas is incredible. So this is a collaboration with the Allen Institute, right? And I would say honestly that they have done most of the work here, so I'm not taking any credit for what happened. But there wasn't a high quality, fully open source mixture of experts model out there for people to play with. That was just a big opportunity, I think, because you can see this trend where everything is moving much more towards smaller models that can potentially be deployed on edge devices. Nicholas had already done some great work with us on GRIT, generative representational instruction tuning, where we.
You guys have done an impressive number of acronyms.
Yeah. It was every new thing we do needs a new acronym. So I recently hired a new head of marketing. He's been complaining about it, actually. So with GRIT, what we show for the first time is that you can use the same model for the retriever and the generator. So the same weights, which means that you can cache a lot of the compute. Because when you think about a RAG system, you have to encode the query basically twice, right? Like once for the retrieval step and once for the generation step. So if you can reuse that compute and just kind of figure out how to combine the parts there, then you can be much more efficient. So what I'm excited by is can we take OMOE and then combine it with GRIT to give you a super powerful RAG system that you can put on your phone. So this is happening very, very soon, I think.
I mean, one thing, it seems like you do a lot of these collaborations, and obviously in another hat you wear, you're like an adjunct professor over at Stanford, and so and obviously came up in the academic world. How do you think about the role academia plays? And obviously a lot of the research coming out of these labs and companies like you, I think traditionally might have been done in an academic setting. And so how do you think about what makes sense for folks at Stanford to focus on versus companies like yourself? Where's that all go?
Yeah, so I think academia is super important for the progress of AI and continues to be extremely important. I think obviously the research that happens in academia has changed, right? So 5 years ago at Stanford, you could still be like seriously looking at pre-training at scale at the time.
Scale is very different.
Yeah. And so now the scale is very different. It's just not really possible to do that anymore at the same scale to get like a full model out, right? But you can still do lots of very interesting research in pre-training just with smaller models. But I think a real blessing, to my point earlier, is that post-training is so important that you can take a pre-trained model that somebody else trained.
Your former employer.
Like, I was going to say that Zuck has generously donated to the world. So from that starting point, you can do amazing research, right, in post-training methods and like better alignment methods, for example. So I think, academia will continue to play a super important role in all of this.
And then I guess, on the enterprise side, I mean, it seems like obviously one of the strengths of what you're doing is this end-to-end solution. So there's no like gaps of things. But I'm sure even, I'm sure you have a wish list of things. You're like, God, if someone else built X thing, that would just be so helpful for us to plug into our end-to-end solution. Like what's top of your wish list these days?
Yeah, it's a very long wish list. So initially, I think we were hoping that we could use off-the-shelf extraction systems.
Yeah.
It's just really hard to contextualize language models properly, right? Sort of hence the name of the company in a way. But so language models are like, most language models are just really good as long as you give them the right context. So how do you give them the right context? You need to do the right retrieval and sort of re-ranking if you have a more sophisticated retrieval pipeline. But you can only really do the retrieval properly if you did the extraction correctly. It turns out that extracting some information from a PDF is very, very hard. And there just isn't anything good out there in the open. So we had to build our own models for doing that. So that's kind of on the beginning of the pipeline. And so, there's just a lot of like kind of boring stuff that needs to happen to build that into a generalizable system. Right? And also on the other end, I think evaluation, especially for enterprises, understanding sort of the risk of a deployment and the real accuracy of the system, is hugely important. But there still isn't really a right way to evaluate systems that enterprises can rely on. So I would love there to be kind of a standard way to do that. We might come out with some ideas of our own in the near future, but that's really like a very underexplored area.
Yeah. Is that like a solvable problem, or does it end up just being really custom and bespoke to like whatever the company's trying to do? Like, and some people have come on this podcast and I think said convincingly, like, part of building a good product is specifying up front what you want it to do, and then you basically created your evaluation set through that, and it sounds much more bespoke, but obviously there's plenty of folks trying to productize this. But
so one of the real problems is that a lot of people don't understand what they want.
Yeah.
Right? So what we do when we have a customer engagement, like we really spend a lot of time just figuring out, like, okay, what do you really want? What does success look like? Then we hill climb together to achieve that success in the sort of prototype setting, and then we productionize it. And I just think that's the right way to do it. I'm worried that a lot of people are not taking evaluation seriously enough. They just have like a spreadsheet somewhere with like 50 examples and then the super high variance. Right? It's not principled enough.
What parts of it then will end up being common though across different customers? I mean, obviously everyone probably has some sort of bespoke nature of what they're doing, but like. It sounds like you think at least there's some sort of common set of tools or framework you might be able to build across. Like, what might that look like?
Yeah, so it's the same system, right? You need to extract information from your data at very large scale, tens or hundreds of thousands of documents and not failing. Then you need to put that in some retrieval mechanism. It's not just one retriever anymore, I think, in modern deployment. So we use what we call a mixture of retrievers approach. And then based on top of that, you contextualize the language model with that information. Then you do a lot of things on top of the language model. So I think like the components there are relatively clear.
Yeah.
And they have commonalities across everyone, but there's still just a lot to gain from making the components themselves more specialized and then sort of tuning the knobs between the components to make everything more optimal.
Totally. I mean, today evaluations are done through like a spreadsheet. Like, in a few years when we hopefully have figured this out in a much better way, like how do you think people will do evaluations?
Yeah, so one idea that we're working on that I'm very excited about is thinking about what developers really need, right? So I think one interesting observation is that what AI developer means has changed over time. It used to be like somebody who could do machine learning and knew a lot about PyTorch and things like that. These days, AI developers often are people who are very good at calling APIs, right? And so I think on the evaluation side, we should have something very similar, right? So instead of having a lot of machine learning traditional knowledge around sort of test set creation and statistical testing to ensure that you have a significant difference between two models, that's all like sort of machine learning data science. It's not what these API AI developers want to use, right? So we're thinking a lot about like what does the evaluation framework look like if you want to make this accessible to developers.
Yeah, makes sense. I guess, switching gears, you've obviously been on the forefront of a lot of this research over the years. I'm wondering, like, something you might have changed your mind on in the last year, like a strongly held AI research belief that you now think differently on.
Yeah, many, right? I think like one part of my job is that I have to change my mind very quickly when things happen, and there's a lot happening in AI. I think, there are lots of them. I think synthetic data working so well was a bit unexpected for me. I didn't really see that coming. I think agents, even though it's still kind of ill-defined what it even means to have an agent, but agentic workflows with tool use, I think is actually much more possible these days than I expected and probably than I would have guessed a year ago. In general, like this kind of like test time compute. So I think when like chain of thought and things like that came out, I thought, oh, that's a cute gimmick, and like you can like tip the language model and we'll do better. And I think a lot of that work was very flawed from an evaluation perspective. But maybe I was a little bit too sort of academic elitist around those contributions, where I was like, oh yeah, that's kind of silly. Like that's not a real like cool machine learning contribution. But it turns out it works really, really well, right? So I think it's really great that the ecosystem is looking at this from so many different ways and combining them in very exciting ways, right? So going back to the where we started, if you roll out a lot of chain of thought things and then you train on those with ROHF, maybe fixing them with either a language model or humans, then you get a more powerful language model. It will be slightly less efficient during test time when it rolls out the actual sequence, but it will give you a better answer.
Right.
It's like, it sounds sort of obvious, right? But I think like the parts themselves didn't feel that special. It's more like when you combine these ideas that we suddenly see these nice.
Also a very challenging data problem. Unfortunately, the internet is not littered with a ton of step-by-step way of doing things.
Yeah, exactly. Yeah, but it turns out that language models are pretty good at thinking through things step by step. Yeah.
Yeah, I mean, a lot of people. You mentioned synthetic data. I feel like a lot of people talk about, in the road to AGI, that like, obviously we're using a lot of the tokens that are out there, and this question of like, where do we get the extra data from? Is that something you worry about? Like, do you think? Okay.
I think that's misguided. I really don't understand where that comes from. I think somebody said this once, and like a lot of journalists kind of picked up on it, and it became a thing like, oh, we're running out of tokens. We produce huge amounts of data as a society every day, and you can train on all of that data. And I don't think we are at the kind of rate of compute where we sort of train faster than we produce data. It's just that not all the data we produce is very high quality as a society. So there's an interesting trade-off between data quality and data quantity. So if you have lower quality, you need commensurately more quantity. I think that's kind of when you ask researchers like me, like, okay, what don't we have enough of? I would say high quality data, but we have plenty of data to train on, and we can still learn from it. We just need much more of it. So that's one observation. I think the other is that that's maybe true for text, but if you go multimodal, like we haven't even scratched the surface, right?
Feels like video data is massive.
So we were talking about like the meaning of cat and like looking at cat pictures, like how many cat videos can you train on to really understand the concept of cat in your huge multimodal transformer, right? We're only just getting started with this stuff. And I think that's one of the shortcomings still. And that's like my PhD was on this, right? One of the big shortcomings of systems is that they don't understand our world. They don't look at our world in the same way that we do. So they kind of observe it by proxy through our linguistic behaviors, i.e. the text we produce on the internet. But that's kind of a poor proxy, right? So if they can actually watch lots of cat videos, they understand much better how humans think about cats. So I think like multimodality is really a great way to add even more data. And then the third point is that there was this paper where they showed that synthetic data doesn't really work, or like you can't train a language model on its own data. But so that paper is full of flaws. It's not actually a realistic scenario. This is again like a sort of PR flag plant, and it killed a lot of very interesting directions because people were like, oh, this is not interesting, I'm going to work on something else, or like probably like companies didn't get funded in synthetic data because this silly
all the data labeling companies were very happy to retweet that. And
yeah, exactly. But synthetic data, if you do it right, is super powerful. And then if you combine that with smarter algorithms like KTO and APO, then you can get super far without needing to do any data annotation and without needing to do like super compute heavy things.
Yeah. What about like reasoning? Obviously, I think we're seeing early signs of it. But like, I'm just curious, like, at what milestone, for you, will you say, okay, this model has, reason? Like, what are you looking out for in terms of this like wave of
I think models already have reasoning capabilities. And they have had for a long time. It's not like that just came out, right? That like maybe OpenAI wants to make it seem like that just became real, and before that it didn't exist. But these models have been reasoning for quite a while, right? So I think that's very interesting. Obviously, they can get better at reasoning still. I think there are easy ways to do that. A lot of it is just data-driven. So this is different kind of data, right? So whereas like high quality, like if you hire a bunch of mathematics PhD students and you make them run through very complicated reasoning, then you can probably learn quite a lot from that. I think if you invest a lot in that data, and I think all of the big like AGI companies are doing that, then we still can improve quite a lot.
Are there milestones that you're, I mean, obviously, I guess they tongue-in-cheek had the number of R's in strawberry as like one of the ones they did. But like, are there kind of milestones you're looking out for? Like, oh, it'd be really amazing when a model can do X. Or...
So I have a fun paper I did with Tristan, who's a PhD student at Stanford, on meta-linguistic tests. It's related to the strawberry one, but it's about self-reference in a way. So like understanding like there are X words in this sentence, like for what X is that true, basically, right? So like self-referential statements like that. And so we had a lot of fun like making this data set and writing the paper. It's called I Am a Strange Data Set. And so I don't know if you know this book from, so Douglas Hofstadter, right, Gödel, Escher, Bach, like amazing guy. He wrote this book, I Am a Strange Loop, where he basically argues that human consciousness is a result of us perceiving ourselves and our own behaviors, and then we sort of come up with a narrative for why this thing that we're observing is behaving that way, and that strange loop sort of becomes consciousness as you grow up. It's like amazing theory, I think. And so I'm not saying that I believe in artificial consciousness or anything like that, but if these systems can actually nail these problems, like that would be very interesting, I think, because that's really like a sort of, like you have mathematics, then you have meta mathematics that reasons about the math, and that's really like something that I think systems can do now, even if they are good at mathematics itself. If systems like score very high on that data set, then I would be very impressed.
Yeah. That's super interesting. Of all the research happening now, I mean, obviously you mentioned chain of thought a few years ago. People were doing all this kind of work. Like, what's happening right now that maybe is like a little underreported that you could see in like a few years? Hey, this could really drive some of the advancements in these models.
So a lot of it is just very practical work, honestly, right? So like I just talked a bit about like mixture of retrievers. It's like, why would you have like one dense vector database? That's really like not optimal, right? So I think a lot of the interesting work, at least that I'm excited by, is just like real, like pragmatic, practical. How do we get this stuff to actually work? And then how do we figure out the right sort of product form factor for a lot of the AI research that we do? Right? So it's kind of a weird new paradigm. It's not like in old school like SaaS or something where you understand what your customer wants and then you just build it, right? There's this much more complicated product pipeline where the product is basically the behavior of your model, which is a reflection of the data that went into it, and maybe like the model that produced that data in the first place, right? So it's just a very, very different way of thinking about products.
Yeah. And that, you know, the idea that like, I mean, I always find it funny that sometimes the most powerful, impactful thing you can do is just like an extra sentence you add to a prompt or something, or like, you know, direct, and like, it's not traditionally what you think of as the, you know, what the 10x engineer would do in a product, but it actually can end up having a massive impact.
Exactly. Yeah.
Yeah. I guess, you know, switching gears to your former employers, you've obviously worked at some interesting places. Maybe starting with Fair, you know, was it kind of always clear that that Zuck would buy a ton of GPUs and give this to the world? And like, what do you know, is this something that can kind of continue going forward? How do you kind of think about that?
No, we never had enough GPUs. Probably the people who work there still complain about GPU shortage.
I don't know if anyone feels like they have enough GPUs.
Yeah, I think Fair is a really incredible place. When I joined it, that was 2016. It was basically like a year old, I think, that they were really kind of taking it seriously. And yeah, it was very, very free and academic, maybe a little bit too free in a way. I was working on like Wittgensteinian language games of like multi-agent systems talking to each other in emergent communication protocols and things. All of that, by the way, is going to come back. Like this year or next year, like I was working on multimodal and that became So I think the thing that comes next after this is sort of multi-agent systems, because it's kind of related to this like systems approach, right? At some point when you have a group like that, it becomes very hard to maintain that kind of freedom, and then there became a bit more like politics and things like that. So it's just very hard, I think, in the long run to preserve this kind of dynamic environment. And I think they did a great job preserving it as long as possible. And they did some really amazing things, right? Like, so, okay, like RAG, it's like, that's cool and cute and everything, but like PyTorch, like that really changed the world, right? And I think probably Fair doesn't deserve enough credit for what happened there. And I think Zuck doesn't get enough credit for being willing to take that kind of bet, right? Like, why give away PyTorch? Like, why give away React? Why give away Llama now? I think it's really visionary leadership that he's doing there. Right?
Why give away Llama? Like, what do you think's behind that?
Well, I think so he was recently on this other podcast, acquired.
We'll let you mention it. If acquired, we'll make an exception for you. You can mention it.
Yeah, so I mean, they filled out.
Did you go to the live recording?
Like, yeah, they filled out the whole Chase Center. So like that's something for you to aspire to.
I don't think we can do the Chase Center yet. You know, we'd have to do some really small local high school gym or something.
That would be fun. Maybe
exactly.
Next time. So I think he had some very interesting observations around like platform, right? So if the new platform is language models or generative AI, it is very important for him to not have to serve that up on somebody else's platform. So I think that's a very pragmatic reason. I also think it does them like great benefit, right? I think like the whole public perception of Facebook, when I worked there, everybody hated Facebook, and I had to like field a lot of like questions around like this is like this evil empire and stuff, and all of a sudden like everybody thinks Zuck is cool, right? He has become
the wardrobe change definitely.
Yeah, he has become a lot cooler after giving that. But so I think people are just seeing the contributions that happen here, and I think it's helping them a lot with hiring. It's really putting them as like one of the top players in the field. They're one of the cool kids again. Totally. Finally.
You mentioned while you were there, you did this work on multi-agent systems, and I feel like that feels like it's coming, right? I mean, I feel like we're seeing all these kind of architectures of, you have agents that are particularly good at things, and then it's how do you coordinate among those agents and have them work together, and you as a person have your like fleet of 30 agents that you're sending off and doing different things. Like, how close are we to that? Like, how do you think about, that feels like another space where demos are going to be really cool, and then actually productionalizing that will be really hard.
Yeah, so in a way, I think we already have that, right? So there are agents, and you can connect agents to each other. And I think when you think about it from a kind of machine learning perspective, like synthetic data is also about agents, right? It's like there's this one agent training this other agent. So I think a lot of this is already just happening. But yeah, I think for me, the broader observation is that we should really not be thinking about this as like monolithic models. We should be thinking about it as systems, and those systems can comprise many models, and those models together need to solve a problem. So that is a multi-agent setup.
Totally.
So yeah, we're sort of already there. I think we're just not calling it that yet. So somebody's PR department at some company is going to at some point make a big splash around that. Maybe.
Yeah, but I'm sure there'll be all sorts of issues in actually figuring out how you get folks to get these agents to collaborate and route the correct
It's a very different optimization problem, right? So that I thought like these emergent communication protocols that emerge when you get these agents to work together, that they might display very interesting like linguistic behaviors that humans also happen to have, and that's actually a reflection of like the organization of the agent structure. Right? So we have some very cool papers where we look at the topology of the agent. So like which agent is connected to which agent? Like, do they all talk to each other, or are they like only connected to the next one sequentially, right? So very different dialects kind of emerge. In
I think everyone's always debating org structure within companies and what the
like culture, exactly, yeah. So like that is getting at culture, and I think like in the even longer run, like humans will be agents in those kinds of like multi-agent systems as well.
And the other agents will decide we definitely don't need to call Jacob for this. We'll maybe if this other thing we'll call.
Hopefully you will still be sort of the CEO controlling all of these agents for you. That's
I guess obviously another place you worked was Hugging Face, and curious, like obviously Hugging Face does a lot of really cool research in a bunch of different places. What do you think the kind of future role of Hugging Face is in this broader AI ecosystem?
Yeah, there's just an amazing company, right? So joining Hugging Face for me was a very different experience from Facebook, because everybody hated Facebook, and it was very different to work at a company.
An emoji logo definitely
everybody
helps,
loves the company. I think Hugging Face really has become kind of the central place for a lot of publishing of things, right? And I think it's maybe a missed opportunity for some of the other kind of more traditional, like so GitHub, where you publish your code. Like why didn't they do the model publishing earlier, right? Or we were actually looking at this with PyTorch as well. Like there was a model hub and everything, and it didn't really take off because it wasn't like properly resourced, I think. But out of that, they built a very special place for themselves, I think. In the long run, I think so. It's a place where you publish models. So they do exist by the grace of Zuck, in a way, and others, right? Like so, they're basically just kind of making money off of other people's open source efforts.
Right. Where do you think they go from here? Like, I mean, is that always kind of what they'll be, or are there other interesting directions that you can build? Obviously it's a place to potentially deploy these models, or
So I think they're doing lots of cool experiments around that, basically, like trying to figure out where to take that. Yeah.
We have a lot of founders on the show and as listeners too, and so I think one thing that's interesting, you obviously have impeccable research credentials. You're building a really interesting company. You've got some great enterprise partners. I imagine people just want to throw money at you all the time, and I feel like this is true of a lot of AI startups, and so. I'm curious how you thought about over the series of, the course of running Contextual, like how much money you should raise. How do you kind of, obviously there's other people that raise insane amounts, like you guys have raised a good amount of money. Like how have you kind of thought about that throughout the journey?
Yeah, so we're trying to be very pragmatic around these things. I see a lot of companies probably raise way more money than they need at valuations that they will have a very hard time living up to. So I think it's important to balance that out, especially because it is likely that the AI hype cycle is going to die off a little bit in the next year or two. And so we're trying to plan for coming out of that as one of the big winners. But I think a lot of companies are going to really struggle when that happens. So yeah, in terms of the money we've raised, I think we've made some like very clear decisions in that we are not going to train our own big base models. Because we know that Zuck is so great. So that means that we can be much more capital efficient, or that we can allocate our capital to other things that are necessary, like having amazing people, and also having these people work very closely with customers to really solve the problems. Right? So I think there's a lot of confusion in the market around the maturity of AI products, where they think like, why can't I just have like a turnkey thing and I just like throw my data at it and everything works? It's like, we are not there yet. So that means that for me as a CEO, we need to think much more about how we can deliver amazing experiences to our customers with like something that in the long run will become a turnkey thing that everybody can just use out of the box, but in the short term needs white glove a bit of more dedicated support. So what I always like saying is, we sell like the Tesla Roadster right now. It's like high-end sports car. It's kind of hard to drive. You need to like tune it properly, right? And so we give you some mechanics and engineers with the car to make sure that it really drives the way you want it to drive. And while we're selling these Roadsters, we're also working on the assembly line for the Model S.
Totally.
That is going to come at some point.
Do you think we're on this like exponential of model improvement where the Model S is coming like literally in 6 months, or like are we on some sort of S curve where like, okay, you know, that there'll be some sort of plateau for a bit, and then, you know, obviously I'm sure you're a bull long term on this, but like, you know, some people are like, look, in a year, you know, these models, it's just going to be night and day. You'll look back at GPT-4 quality models and laugh. And other people are like, well, I don't know. Actually, it seems like there needs to be some sort of algorithmic breakthrough.
Yeah, so I think we're really only just getting started with a lot of this stuff. But I do want to point out that the things coming off the assembly line, the cars are systems, not models, right? Yeah. So I think like a lot of people still talk about scaling laws and things. But at some point, you don't really have to scale anymore because there's so much other stuff you can do to make it better, right? So you just scale up to a certain point, and then you do a lot of like post-training around that pre-trained point, and then you do things like, you know, chain of thought and like distilling that back into the model, to like taking the systems thinking and putting it back into the model. So there's just a lot to be gained from doing that too. So we're kind of scaling in many directions. Right. So yeah, I think there's a lot of exciting stuff still ahead of us.
Yeah. Well, we always like to end our interviews with a quickfire round where we get your take on a few common questions. And so maybe to start, would love one thing that's overhyped and one thing that's underhyped in the AI world today.
Yeah. So overhyped and underhyped, I think, is agents actually. so they're in a way they're really overhyped. It doesn't really work yet, but they're underhyped because like it is showing signs of life, I think. So yeah, that's probably the one that springs to mind at first. Yeah.
Nice. And then what's been the biggest surprise in building Contextual? I guess, you know, maybe an example of one thing you thought would work and it didn't, or one thing you were like, I don't know, it was a random experiment and actually worked really well.
Yeah. Yeah. So what I think like when you are not in a startup, you think that a lot of the kind of infrastructure things are easy, right? Like, let's just have a cluster that works. Like we kind of assumed, I think, that was a given. It turns out that having like a high-end research cluster that actually works is incredibly hard. And even if you look at like the latest Llama paper, they have some stats about how often they had hardware failures. Yeah. It's amazing how often they had to like swap out GPUs or even entire nodes, right? So the infrastructure that we're using to build a lot of this technology is a lot more fickle than you would think.
I know this isn't a one or the other, but obviously people love to debate closed source versus open source models, and so I'm kind of curious, you know, which one you think will be the dominant usage for most business use cases long term? Is it state of the art closed models or actually much more specific, you know, open source models?
I think a mix, right? But I guess I'm a little biased here. But so I used to always talk about this as sort of a triangle, where at the top of the triangle you have these high-end closed source models that are kind of frontier, right? They're also more expensive. Then at the bottom of the triangle you have these open source models. Everybody can access them and like do things with them. The most interesting part is sort of the middle of the triangle, where you get the right trade-offs. Between sort of like capital efficiency for the company, for like usefulness for the customer, like serving it up at the right price point, right? So I think if you start from open source and then you have an amazing post-training capability, then you can just do a lot on top of that to end up in the sweet spot, sort of in the middle of that triangle where you have the right trade-offs.
Which AI startup outside of your space are you most excited about?
So I've been really impressed by where sort of AI-based entertainment has been going. So sort of like Suno and things like that, right? And like all of the video generation companies, and there's just, that is going way quicker than I would have thought.
We had Mikey on the podcast, and I feel like that's the one I'm always trying to, like, you know, show my family like this cool demo, that cool thing, and Suno's the one that's like that's stuck. Yeah. It's a really compelling, and the video stuff is also really cool. It obviously just feels very early.
So it feels very early, but it's still going quicker than I would have thought, and so you can just extrapolate where that's going to go, right? Like in 10 years, we are not going to watch one movie anymore. Right, there's like everybody will watch their own personalized movie, right? Or you can watch like infinite episodes of whatever your favorite show is. Or you can make up a new ending to Game of Thrones that is actually good, right?
If all of humanity focuses on that, hopefully someone comes up with a better one.
Well, so everybody will get their own personalized ending.
Yeah, I guess it would be different
that is optimal for them, right?
Yeah.
So there's just a lot of like personalization.
I'm not sure anyone will stick with the existing one, but there's got to be someone out there that was optimal.
Well, maybe the directors, I guess, of the show, right? They thought it was great. So.
What company besides Contextual do you think would be like most interesting to run AI at if you could just plop you in anywhere?
Yeah, there are obvious answers, like sort of Google or like Meta or something like that. But I think because of what I'm currently working on and what I'm most interested in, I think actually a lot of the cool stuff in AI is about how to turn it into real usable products for people, right? So if you think of like, I don't know, JP Morgan or something like that, like think of all the amazing problems that their head of AI gets to solve. Using all of this amazing technology. I think this is some episode in the 40s, and this is the first time someone's answered JP Morgan. That's a good. I don't know when the next 60 will win that either. I love it. Yeah. No, but so like all these like more traditional enterprises where suddenly you encounter this like new technology that's going to change everything, and if only you can figure out how to do that before everybody else, you have this massive opportunity. I think that's very exciting.
If you weren't running Contextual and it was you were building an AI application, like what application would you build?
Probably also something in the entertainment space. I think that could be very interesting. It's kind of hard to choose, honestly. Like so for us, I think like in most alternative futures, I would still end up working on Contextual because I think like work is the most obvious place where this technology is going to change everything, right? So, and like our company mission is to change the way the world works, like through AI. If we can really make that better for everybody, I think that is a very noble mission and will have huge impact. So that's the thing I would focus on in most alternative futures. But
well, the nice thing about this personalized entertainment is you'll be able to make a movie of yourself having done 100 different companies. And
exactly.
You can see how
you still have your alternative futures that way.
Well, this has been a fascinating conversation. I'm sure folks are going to want to pull on lots of threads of things we talked about. I'll leave the last word to you. Where's the best place for people to go and learn more about your research, Contextual, anywhere you want to point them?
Yeah, contextual.ai. Follow me on Twitter. My name is hard to spell, but you can find it. There's only one person in the world with my name.
Impressive.
Parting thoughts. I think like we're just really at this amazing point in history where we get to see the world changing in front of our eyes, changing how the world works. Exciting times ahead for everyone, I think.
Yeah. Well, thanks so much for coming on. This was a fascinating conversation.
Thank you.